Excellent. All right. So we're going to start off. I'm going to ask you this question: Where do you think that we get adder, reader, and assert equal from? I'd like you to spend 3 minutes in your notebook, and let me. And I'll share these notes with you in Slack whenever Slack comes back up. But where do you think we get the ability to call methods? Let's take 5 minutes and write in your notebook what we think. Take about another 2 minutes to get our thoughts down on paper. All right. Alex asks, what do you think?
I'm going to kind of guess based on the lesson title that it has to do with inheritance. It's an object or something like that. I don't know if it's we inherit from base object. I don't know. But.
Yeah,
my
and
guess.
so yeah, totally. Totally. The idea is that what we're trying to figure out is like, hey, we're working with methods here when we're dealing with Ruby, and like we never define these methods, so they have to come from somewhere, right? And the idea here is that it kind of goes looking somewhere else. And the big picture, like inheritance, is one of the tools that we use. That it allows us to use. Inheritance allows us to use code defined in one class in multiple classes. This is one of the tools that we use in addition to modules, which we'll cover later on this week, to kind of reduce code duplication. So we're not reinventing the wheel. We don't have code that exists in multiple places. From Sandy Metz's Pooter, practical object-oriented design Ruby, she defines it as, I'm just going to copy and paste this because I do not want to type today. Inheritance is its core a mechanism of automatic message delegation. It defines a forwarding path from not understood messages. And we've kind of talked about this previously in this kind of idea of scope, right? Where like, well, if we're in a method and we are looking for this name, it's going to look for local variables inside that method. And if it can't find it, it's going to look for the siblings. And then this is like kind of like the path things take when we try to find things that are not inherently obvious to us. So when hopefully this looks familiar when we do a require test. Right. This should look a little familiar to you. And the idea here is that what this is doing, this bit here in particular, is that for this class, we want to inherit the characteristics and behavior from the test class of the main test module. So we're bringing in the kind of behaviors that we get from the test object, right? And so that's where we get the assert equal, all those assertions and all those methods, all that extra kind of features that we get when writing tests. We're pulling that in from the test, and this is kind of like the syntax that we're used to inherit that. And so there's a couple things to remember when we are inheriting rules. Number one, the objects model. Typing is hard today. Modeled using inheritance must demonstrate generalization, specialization, relationship. We're going to talk about that a little bit more in detail in a little bit. When a class inherits from another class, it receives access to all of the methods and instance variables from that other class. And this is kind of evidence is when we inherit from test to bring that information in our test. It's not like, oh, I'm just going to take this method, that method. No, like we get all of them, right? Like there's no picking and choosing. You get the whole shebang. The inheriting class is called the child or the subclass. The class being inherited from one word superclass. Cool. Oops, that needs a point there. A class can only inherit from a single parent. This is also known as single inheritance. More defined terms, the chain of parents and so forth are called its ancestors. We're really kind of leading to this whole child-parent analogy. Any class can have multiple subclasses. And so, as we said, inheritance is a way we can share code across classes. And when we talk about this generalization, specialization relationship, we kind of want to use it where there's what's called is a relationship. Oops. Is a relationship. And so an example of this is that let's say I was going to model like a dog class, you know, a dog is a mammal and so forth. Cool. So the idea is that when we are trying to use inheritance, what we do is that we have some kind of general class that we use for all the things, and then we have subclasses that inherit from the larger class. And that this is all very abstract right now, but let's just get started with an example. All right. So what I'm going to do is that in here, I'm just going to make a employee file. And it's going to look like this. And in this method, in this class, I'm going to have def total compensation. And this method is going to be base salary plus bonus. Excuse me. And then we are going to model a CEO. And what that's going to look like is that first I want to do is that the idea here is that I'm creating this relationship. A CEO is a kind of employee, right? And so the first thing is that I'm going to have the CEO object inherit from the employee object because a CEO is a kind of employee. And to first do that, I'm going to need to require it. Right? And we're going to do class CEO, and that inherits from employee. And we're going to do end. Why do I keep hitting that button? Cool, employee, and then we're going to do reader. All right, and then I'm going to make a runner file. And here I'm just going to acquire CEO. New, and we're going to get Allie's going to make a base salary of 15 ducats, and the bonus is 20 ducats. And then we're going to do, oops. Puts Allie dot total compensation. And if I run this, I should be able to get, I should see 35 because the base salary is 15, the bonus is 20. And we get that 35. Jake?
I might be getting a little ahead of myself with this question, But with this concept of inheritance, obviously it requires an instantialization at some point.
Yep.
But using this example of employees, if someone's hired right away as a CEO, there's no issue. But what if someone was like SVP and then they get promoted to CEO? Do you have to delete the initial instance when they were a VP and then reinitialize them as a CEO, or can you essentially
probably, yeah,
right?
Because you want to change the kind of object it is, so you'll have to reinitialize it.
Right, so it's between like an attribute and an instance or something.
Yep.
Okay.
Yeah, you'd have to reset that. But as we can see here from this runner file, we're just creating CEO, and we see here that we've not instantiated an employee object at all. All we've done is instantiate the CEO object. The CEO object inherits from employee, and because it inherits it, we have access to this method that we've created here, total compensation. Like nowhere in this file, in the CEO.rb file, have I defined the total compensation method. So when what we can see here is doing is that here we're going to have access to the method we've created here. Right. And so again, we have access to total compensation in our CEO class because it inherited from employee. In this specific, example, the CEO is the subclass or child, and the employee is the superclass or the parent. We still define methods in CEO, like initialize, we can have extra things done here. Hua?
Sorry, I must have missed this when you explained it, but I see that the CEO is less than employee. Is that just you trying to, do we have to do that to make it like as a child of the employee?
Yes, this is saying that CEO, you are going to inherit from the employee class.
Okay, and we still need to require no matter what.
Yes, because otherwise you won't see the file. Like if we don't do this, then we don't have access to the thing.
So if we have to require, but we don't really have the less than employee.
It'll say no error, no method, total compensation. So I can actually let's just take this out.
Okay.
Mm-hmm. Yep. Undefined method, total compensation.
Interesting. Thank you.
It doesn't see that. Yep. Karen?
So I guess I'm just looking at employee and CEO. So CEO has a base salary and a bonus. But wouldn't all employees have a base salary and a bonus? So, yeah. Mm-hmm. Okay, would that belong in the employee class?
No, because we're initializing it here. Like this is where we're initializing this kind of stuff here. And we're just saying that employee, all we're doing in employees, we have a method that adds the two.
Yeah, and I guess I'm thinking about it practically, like wouldn't all employees have a base salary and a bonus?
Not necessarily.
Okay.
Mm-hmm. Ben?
Yeah, so I was just thinking about like what happens if you have an inheriting, like let's say the employee class had some instance variables, but then you didn't want a class that was inheriting from it to have some of those instance variables. Like if you wanted to limit what that class had, or change, how would you?
I mean, the idea is that like in the general case like that, and then you would not structure it this way.
That's
the
true.
idea is that the superclass is going to be kind of like shared behavior, and there'd be there'd be like exceptions. You want to only put the generalized stuff in the superclass. Cool. Other questions so far? All right. So what we're going to do is going to break you up into groups. And this is going to be annoying because Slack is still down. But in the lesson plan, which I will put in the chat right now. Oh, you're already somewhere already posting there. What you're going to do is that the try it section, you're going to create a sales manager class that inherits your employee, takes base salary, and you estimate annual sales as arguments. Those three items, we're going to give you 10 minutes to do that as I break you out into groups. Dun, dun, dun. Cool. We'll see you in 10 minutes.